again with you all with a new topic of mathematics, that is arithmetic progression. In our day-to-day life, we come across so many patterns. Like there is a pattern in the textured wall. If we see there is a pattern in the tiling, we can see the pattern in the bed sheets also. But if we see it mathematically, then also in the previous classes, we came across so many patterns. Like if we take an example, 1, if we are going to take the sequence 2, 4, 7, 11 like this. Another pattern could be 1, 4, 9, 16. So there are some sequences which is following some pattern. So these type of sequences which is following some patterns are known as progressions. So in these sequences, there is a pattern, they are following the pattern by which we can come to know that what will be the next term. Every number in the sequence is known as term. That means 1 is one of the term, 4 is even one of the term, 9 is even a term, 16 is even the term, and then keep on coming, there will be so many terms will be coming. So over here in the first sequence, if we will see that in the first 1, we have added 1 and we got 2. In 2, we added 2, we got 4. In 4, we have added 3 and we got 7. Now, if we will add 4, we will be getting 11. That simply we can come to know that the next term will be, if we will be adding 5 in 11, that will be 16 will be the next term. That means by seeing the patterns, we can come to know that what the next term will be. In the second sequence, if we will see, 1 is the square of 1, 4 is the square of 2, square of 3 is your 9, square of 4 is 16. That simply means the next term will be 25, that will be square of 5. So in these type of sequences where we are following some pattern and by that pattern we will be knowing what the next term will be, these type of sequences are known as progression. Now let's see what arithmetic progression is. Arithmetic progression is basically a special type of progression in which we are getting the next term, that means the succeeding term we are getting by adding a particular or fixed number in the previous term. That means if we take an example, suppose I have started it with 1 and the next number we are getting by adding 5 in it. So next term will be 6, then again I will be adding 5 in it, it will be 11, then again I will be adding 5 in it, we will be getting 16 and so on. That means not the first term is not following the pattern, the rule is not applicable for the first term, but except the first term, whatsoever the next term we are getting by adding a fixed number in the previous term. That means in the first term we have added 5 to get 6, then again we have added 5 to get 11, like that the sequence will be. Another type of sequence could be, number could be 5, starting from 5, because the first term is not following the rule. Except the first term, the next terms will be getting by adding a particular or fixed number in the previous number. So if I will be adding 10 in it, it will become 15. Then again the same number 10 will be added in it to become 25. Then again it will be 35, so on. So these type of progressions where the next term we are getting by adding a fixed number in the previous number, such type of progressions or the sequences are known as arithmetic progression. These are special type of progressions only, where whatsoever the next number we are getting or with the succeeding number we are getting by adding a fixed number in the preceding term. Every number is known as term, as just now we discussed. So these type of progressions are known as arithmetic progression. Here the rule of adding is not applicable for the first term. Except the first term, you will be adding a fixed number in the previous number to get the next number. So the first term is denoted by small a. The terms, whatsoever the first term of the sequence is there, that is denoted by small a. It is your first term. And the difference, common difference which we are adding, means the fixed number which we are adding in the previous number to get the next number, is known as common difference. Common difference, and it is denoted by small d. That means the first term is denoted by small a, and the fixed number which we are adding in the previous number to get the next number is denoted by small d. If the number of terms is your finite, that means we are having the last term also, that means total fixed number of terms are there, then such type of APs are known as your finite AP. That means if we are having the last term also, total number of terms or a limited number of terms we are having in the AP, then such type of term, your AP is known as finite AP. And if it is not limitless, that means dot 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 are there till end, then it is known as infinite AP. These type of APs are known as infinite AP. Arithmetic progression is abbreviated as AP. Wheresoever we are using the term AP, that simply means arithmetic progression only, because arithmetic progression is abbreviated as AP. So we came to know that whensoever we are adding a fixed common difference in the previous number, we are getting the succeeding number. Now the important point is the number which we are adding in the previous number to get the next number could be positive, could be negative, and could be 0 also. Now let's see few examples related to it. Here the number which we have taken, that means common difference which we have taken was positive. Here it was plus 5 and here it was plus 10. Now suppose your sequence is 10, 8, 6, 4 like that. Here we are not adding, we are not subtracting 2 from the previous number to get the next number, because we just now said that in the previous number we are adding some number to get the next number. That means in this previous number we are adding minus 2 to get the next number. Minus 2 is added in 10 to make it 8. Now the same number will be added in 8 to make it 6. So that will be your minus 2. If this number is common for all the terms or the coming terms, then such type of sequences is your AP. So here we can see if we will be adding minus 2 in 10, we will be getting the next term. When we will be adding minus 2 in 8, we will be getting the next term. Similarly, if we will be adding minus 2 in this 6, we will be getting 4. So suppose if it is ending at 0. This sequence is ending at 0. That means limited number of terms are there in the AP. Such type of APs are known as infinite AP. And if it is limitless, the number of terms is not fixed, it will keep on going, then such type of APs are known as infinite AP. So this is the example when your number, yani common difference which we are adding is your negative. These were the examples when the common difference which we were adding were positive. Now one more example we can take. If your sequence is 7, 7, 7, 7 like this sequence is even an example of AP. Why? Because in this number we are adding 0 to get this number. In this number again we are adding 0 to get the next number. Again in the previous number we are adding 0 to get the next number. That means the number which we are adding could be positive, could be negative, and could be your 0 also. In all these cases, these are examples of AP only. Now we can see, just now we have said that the first term is denoted by small a and your common difference is denoted by small d. That means how we can get the value of small d, common difference, because we are adding this common difference in the previous number to get the next number. That means if your first term is denoted by a1 also, that means a is equivalent to a1 only, and the second term is denoted by a2. In that case, a2, how we are getting a2? If we are adding common difference in the first term, then we are getting the value of your a2. Similarly, if in a2 second term we are adding the common difference, we are getting the third term. That simply means common difference we can get by subtracting the previous number from the next number. If we will be subtracting a1, the first term, from the second term, we will be getting d. Similarly, if we will be subtracting second term from third term, we will be getting D, because this D is common throughout the series. That means it will be remain same whether your term, whichsoever term you want to take, you need to subtract the previous term from the next term. That means it is even equivalent to A4 minus A3. That simply means we can say that value of D, that is common difference, could be an minus 1, where A could be any positive number. So the value of common difference we can get by subtracting the previous term from the next term. Just now we have seen that the first term of the AP is either denoted by A1 or we can write it as A also. The second term of the AP we are getting by adding the common difference in the first term. That means in the first term, that is A, if we will be adding the common difference D, we will be getting the second term. Now the third term we will get by adding the common difference in the second term. That will become your A plus 2D. Now for finding the fourth term, we will be adding common difference in the third term, that is A plus 2D plus D, that we can write it as A plus 3D. So here we can see that in the first term, there is no A is there in the first term, that is it is only A. In the second term, there is one multiple of D, one D is there. In the third term, there are 2 times of D. In the fourth term, it is A plus 3 times of D. That means in every number, in the every next number, if it is 2 second term, it is 1D coming. If it is third term, that it is 2D is coming. In the fourth term, it is 3 times of D is coming. That means we can say that in the nth term, it will be n minus 1 times of D. In the first term, it was simple A. In the second term, 1 times of D. A was added with 1 time of D. In the third term, A was added with 2 times of D. In the fourth term, A was added with 3 times of D. That means if it is nth term, so it will be A plus n minus 1 times of D. So we can say the general form of an AP is A, that is your first term, then your second term, then your third term, fourth term, like this. It is the general form of the AP, and by this we can find the nth term of an AP. Whatsoever if we are having the sequence, if we are having the AP series we can find the nth term of the AP using this formula. Suppose I am taking the series as 5, 10, 15, 20 and so on. So here we can see that the first term of the AP is 5. Common difference, if we are going to see, if we will be adding 5 in the 5, we will be getting 10. If we will be adding 5 in 10, we will be getting 15. That means common difference is your 5. And how we can get the common difference? Common difference would be A2 minus A1. From the second term, if we will be subtracting the first term, or from the third term, we will be subtracting the second term, we will be getting the common difference. So common difference will be second term is 10 and the first term is 5. So the common difference is 5. Now we are having the value of the first term. We are having the value of the common difference, that is D. Now if we have to find the 20th term of the AP, what will be the 20th term of the AP, this AP, then here we can say the value of n is 20. So if we will keep this over here, the 20th term will be A is your 5 plus n minus 1, that is 20 minus 1 into D is your 5. So by using this formula, we can find what will be the 20th term of this AP. We can find any term of the AP by using this formula. So it will give us 5 plus 20 minus 1 will be 19. 19 into 5. That will be 5 plus 95, or we can say it will be 100. 100 will be the 20th term of this AP. So the nth term of an AP we can find by this formula, and nth term of an AP is denoted by AN. nth term, because first term is your A1, second term is A2, third term is A3, fourth term is A4. That means nth term of an AP is denoted by AN, and using the formula A plus n minus 1 into D, we can find the nth term of an AP. This is the example we have taken just now. Now, if we are having the finite number of terms in the AP, suppose I am taking this series only. Suppose I am saying 5, 10, 15, 20 till 100. That means over here, so there was no limit, infinite number of terms were there. So it was an infinite AP. But over here, the limited number of terms are there because we know the last term. That means it is having a finite number of terms. This means it is an example of finite AP. So the last term of the AP, if it is given to us, then it is denoted by small l. The last term of AP is denoted by small l also. So this is your small l. The value of small l is 100. And if we have to find, instead of from starting 20th term, suppose we have to find the 5th term or 10th term from the last. From the last we need to find. So for that, the formula will be L minus n minus 1 into D. Using this formula, we can find the nth term from the last. Now suppose we have to find the 5th term from the last. So here the value of L is 100 because L is the last term. Value of n, because we have to find the 5th term, that means value of n is 5. And here we can see value of D is A2 minus A1, that is your 10 minus 5. Value of D is 5. So value of D will be 5 only. So if we will be keeping all these values in this formula, it will become last term minus 5th term from the last we want, and value of common difference is 5. So it will be 100 minus 5 minus 1 will be 4. 4 multiplied by 5 will be 20. So the last term from the last term, the 5th term from the last will be your 80. We can check it out. This is the first term from the last, then it will be 95, then it will be 90, then it will be 85, and then it will be 80. So first term, second term, third, fourth, fifth. Fifth term from the last will be 80. Just keep in mind that D will be positive only from here, whatsoever that value of D was, and we will be taking that only. We won't be considering D from here, so it won't become negative. It will be taken whatsoever the D from here it is, original AP, that only we will be considering. So using these formulas, we can find the general form of AP as A plus D, A plus 2D, A plus 3D, like that. The nth term of an AP will be, using this formula we can find the nth term of any AP. If we know the value of the first term, if we will know the common difference, then we can find the nth term of any AP. And if we have to find nth term from the last of an AP, using this formula, we can find it out. Hope it is clear. And if the value of A and D is given to us, if we know, suppose we are saying the value of A is 10 and value of D is say 20. So if we are having the value of A and we are having the value of D, we can frame the sequence also. We can frame your AP also. How we can do that? So first term is your 10. So 10 we will be taking. The second term we will be getting by adding common difference in it. So 10 plus 20 will become 30. Then third term will be when we will be adding common difference in this term. So 30 plus 20 will become 50. Then 50 plus 20 will become 70. So if we are having the first term and the common difference, we can frame the AP also. Now let's understand some examples related to what we have learned till now. The question number 1 is, identify which of the following is an AP. Means sequences are given to us. We need to check whether these sequences are forming an AP or not. Here we can see the first term is root 2. The second term is root 8. The third term is root of 18. So see, if we will factorize 8, it will be 2 multiplied by 2 multiplied by 2. 8 could be written as 2 multiplied by 2 multiplied by 2. So if we will be finding the square root of it, 1 2 will come out of it. It could be written as 2 root 2. Similarly 18, if we will be factorizing 18, so root of 18 could be written as 2 multiplied by 3 multiplied by 3. That means 1 3 will come out and it will become 3 root 2. Similarly, if we are going to see for 32, root of 32 could be written as root of 2 into 2 into 2 into 2 into 2. That means one pair of 2 from here, another pair of 2 from here, we can take it out. That means 2 multiplied by 2, 4 we can take it out. We can write it as 4 root 2. So the first term is root 2. Second term could even be written as 2 times of root 2. Third term could be written as 3 times of root 2 and it is your 4 times of root 2. If there is any sequence, we can say the sequence is in AP if the common difference is same throughout the series. That means if there is a common number, if we will be finding the value for first two terms, a value of D from second, third term, value of D from the next. If it is coming same for all the conditions, then we will say that the series is in AP. Now from the first two term, value of D will be A2 minus A1, that is 2 times of root 2 minus root 2. Root 2 could be taken common from here. If we will take root 2 common, it will be 2 minus 1, that is root 2 itself. That means from first to A1 and A2, value of D is over here is root of 2. If in root 2 we will be adding root 2, we will be getting 2 root 2 or we will be getting root of 8. Now, if we will see here in this condition what is the value of D. So here D will be A3 minus A2. A3 is your 3 root 2 minus A2 is your 2 root 2. Again root 2 could be taken common. It will be 3 minus 2, that is 1, means root 2 only. That means for the second condition also D is root 2 here. Means in the second term we have added root 2 and we got the third term. Similarly, we will be checking for this condition even. That means we will be checking for D is equivalent to A4 minus A3 even we will be checking. And we will be getting same, that is your 4 root 2 minus 3 root 2, that is your root 2 only. So for all the condition, the value of D is same. So we will say that the series is in AP. Because whensoever your D, common difference which we are adding in the preceding term to get the next term, if it is same throughout the series, we say the series is in AP. Now we will be seeing the second question. It is your 4, 4, 6, 6, 8, 8. Now here, from here to here, from first term to second term, your value of D is 0. Because in 4 we have added 0 to get 4. From second to third term, it is your from here if we will say, so A3 minus A2. A3 minus A2 is your 2. That means here value of D is 2. The number which we have added is 2 over here. Here again it is 0. Here again it is 2. But it should be same throughout the series so that the series will be in AP. But because the value of the common difference over here is not same, alternatively it is 0 and 2, although it is forming a pattern, but still it is not in AP because common difference is not same throughout the series. So it is not in AP. Now see the second question. If nth term of a sequence an is given by 2n square plus 1, find first 3 terms. It is a sequence is given. It is not compulsorily that whatsoever the sequence will be formed, it will be in AP. It is not compulsory. But whatsoever the sequence will be formed, we have to find the first 3 terms of that sequence. Now here n. First 3 terms means we have to find the first term, second term and third term. That means for the first term, value of n will be 1. So when n is equivalent to 1, the first term, that is your A1 will be, we will be keeping, instead of n we will be writing 1. It will be 2 multiplied by 1 square plus 1, that is 1 square will be 1 only. 1 multiplied by 2 is 2 plus 1, that is 3. So first term of the sequence is your 3. For finding the second term, we will be keeping n is equivalent to 2. So it will be second term, that is A2. Now wheresoever n is coming, we will be writing 2. So 2 multiplied by 2 square plus 1. So 2 square will be 4. 4 multiplied by 2 will be 8. 8 plus 1, it will be your 9. It is the second term. For finding the third term, we will be keeping n is equivalent to 3. So if we will be keeping n is equivalent to 3, it will be third term, that is a3. For that we will be writing, instead of n we will be writing 3. So it will become 2 multiplied by 3 square plus 1. So square of 3 is 9. 9 multiplied by 2 is 18 plus 1, that is 19. So first term of this sequence is 3. Second sequence is 9. Third term is your 19. We can see from here that here the number which is added means value of d over here is 6 and value of d over here is 10. That means this sequence is not in AP. It is simply a sequence, but it is not in AP because value of d is differing. It is not same. Now the third question is, for an AP, if the value of a is minus 18, n is 10, means nth term is 0. Nth term is 0, what will be the value of d? Here we have just read that for finding the nth term, the formula we use is nth term of an AP is a plus n minus 1 into d, because it is given to us that the series is in AP. So we will be writing this formula, an is equivalent to a plus n minus 1 into d. Nth term is 0, that means an is given to us as 0 and we have to find the value of d. So we will be keeping all the values here in this formula. An is given to us as 0. It is equivalent to a is minus 18 plus, we have to find the 10th term, n is 10. So it is your 10 minus 1 and we have to find the value of d here. So this minus 18 will come over here, will change the direction. It will come in LHS part and will be positive 18. So it will become 18 is equivalent to 10 minus 1 will be 9. It is your 9d, or we can say value of d is 18 divided by 9, that is 2. So value of d will be 2. So by simply using the formula, we can find whatsoever is given, we will be keeping in the formula, and whatsoever is remaining, that is what is asked, accordingly we will find the value of that. Till now we have seen how to find the nth term of an given AP. Now let's see how to find the value of sum of first n terms of an AP. If an AP is given to us, a series is given which is in AP, then how to find the sum of first n terms of that series, that AP. Now as just now we said that the first term is your a, second term is your a plus d, third term is your a plus 2d, and the nth term is your a plus n minus 1 into d. So sum of all these terms will be denoted by Sn. Sn will be sum of all these terms. Sum of all these terms is denoted by Sn. Now instead of writing in the forward direction, if we will write it in the reverse direction, then also the value will be same, because it is following the commutative law for addition. Right, we can change the order of these numbers, these terms we can change the order. So this term we will be writing in the first. So it will be a plus n minus 1 into d, plus the second last term from here will be a plus n minus 2 into d. That will be the term. Like this we will be writing, and here your first term will come, that is your a. Now if we will add all these two, means suppose this is your first equation and this is your second equation, and if we will add these two equations, the sum of these two will be a plus a will become 2a. This a and this a will become 2a plus n minus 1 into d. This will be the sum of these two terms. Now here again if we will be adding, it will be 2a plus n minus 2 times of d and 1d. So it will become your n minus 1 times of d. Here again if we will be adding, it will be the same, and here a plus n minus 1 into d plus a will be 2a plus n minus 1 into d. And these sum is equivalent to Sn plus Sn, that is 2 times of sum of n terms. So we can see that 2 times of sum of n terms is all these terms are coming equal. They are coming same. And how many terms are there? Total of n terms are there. Because it is sum of n terms, so this will be total of n terms. If every term is 2a plus n minus 1 into d, so addition of these n terms will be 2 times of Sn will be n multiplied by 2a plus n minus 1 into d. Because n times the same number is being added, so sum of all these n terms will be n multiplied by 2a plus n minus 1 into d. So this is the value of 2 times of Sn, that is 2 times of sum of first n terms. So sum of n terms will be n by 2, 2a plus n minus 1 into d. This is the formula which is directly used for finding sum of n terms. If the series is in AP, then we will be directly using this formula, and by using this formula we can get the sum of first n terms of the AP. Now if the last term is given to us, as just now we said that this, if your series is finite series and this is your last term, so last term is even denoted by your L also. So a plus n minus 1 into d, here it is your 2a. So 2a could be written as a plus a also. So one single a plus n minus 1 into d could be written as your last term also. So this formula could even be written as n by 2 a plus L, where L is your last term, means sum of first term and last term multiplied by number of terms n by 2. This could even be used if the first and last term are given to us. And just now we said this is your last term or nth term. So Sn could even be written as n by 2 a plus an. That is your nth term. So any of these formula you can use as per your convenience. Whatsoever is given to us, accordingly we will be selecting. If the first and the last term is given to us, we will be using these formula. If it is not given, if the value of a, d, n is given to us, we will be using this formula for finding sum of n terms of an AP. Now if this is the formula, another formula we can derive from here is for finding an. Just now what we learnt is an is a plus n minus 1 into d. This is the formula for an, finding the nth term of an AP. But in terms of sum of the numbers, also we can find the value of an. How we can get it? So an could be Sn minus 1. How we can find it out? Just check it out. Suppose a series is there, 1, 2, 3, 4, 5, 6, 7 like this. Now we have to find, suppose I am taking this series only. This say here we have taken the first term as 1, that is a is 1, and here your second term is 2, that means value of d is 1 only. So a is 1, d is also 1. So whatsoever that term is there, that number is only the value of that term also. Means first term is 1, second term is 2, third term is 3, like that only it is. So for finding, suppose 10th term. So what we will be doing for finding 10th term, it will be sum of 10 terms minus sum of 9 terms. If we will be adding, suppose I am taking it till 10, 8, 9, 10. We have to find this 10th term. So if we will be adding all these 10 terms, it will give us value of S10. And if we will be adding first 9 terms, then it will give us the value of S9. And if from S10 we will be subtracting S9, we will be getting the A10, means 10th term we will be getting. So by this formula even we can find the nth term. If some of the terms is given to us, so by using this formula, from means nth term we have to find. So we can find it out by subtracting sum of n minus 1 terms from sum of n terms. If we will be subtracting, we will be getting the nth term of the AP. So either this formula we can use as per convenience, whatsoever is given to us in the question. If sum of terms is given, then we will be using this formula. Otherwise we can use simply this formula. Now the sum of first and positive integers, that means this is the series which we have to consider. first n positive integers we have to take. So this is the series. Again this is an AP, and we have to take nth term till n, means first n positive integers we need to take. So we have taken first n positive integer, and we have to find what will be the sum of these first n positive integers. So we will be using this formula. Sn is equivalent to n by 2, 2a plus n minus 1 into d. Here we can see that the first term is your 1 only, and common difference is a2 minus a1, that is 2 minus 1, 1 only. So value of d is also 1 and value of a is also 1, and value of n is n only because we have to find the sum of first n terms only. So Sn will be n by 2, 2 into 1, we are keeping the value of a as 1, 2 into 1 will become 2 only, plus n minus 1 into d is 1 only. So we will keep it as n minus 1 only, because n minus 1 multiplied by 1 will give us n minus 1 only. So n by 2, this bracket we are solving, it is 2 plus n minus 1. 2 minus 1 will be 1, so it will become n by 2, in bracket it is n plus 1. So this is the formula for finding sum of first n positive integers. Directly we can use the formula Sn is equivalent to n plus 1 by 2. Using this formula directly we can find sum of first n positive integers. From this formula only we have derived this formula also. So we can find, so if series is given to us, we can find value of a, we can find value of d, and whatsoever the number of terms, the sum of these terms we need to find. Using the formula we can find the sum of these number of terms. And if your sum is given, sum of n terms is given and sum of n minus 1 terms is given, or any means algebraic expression is given by which we can find the sum of n terms, in that case nth term we can get by subtracting Sn minus 1 from Sn. This formula could be used. And if it is sum of first n positive integers, then this will be the formula, that is Sn is equivalent to n plus 1 by 2. Using these formulas, we can use these formulas for solving multiple type of questions. Now here are some important things to know, that if A, B, C are in AP, that means these are the consecutive terms of the AP, then the middle term is known as the arithmetic mean of these three terms. Why it is so? We know that if the common difference of this AP is your D, that means if we will be adding A and D, we will be getting the next term B. In this first, suppose it is first term, it is second term, it is third term. So in the first term, if we will be adding the common difference, we will be getting the second term. And in the second term, if we will be adding the common difference, we will be getting the third term. So see, from here, we can say that the value of B could even be written as C minus D. If this is your first equation and this is your second equation. And if we will add these two, B and B we are going to add, and A plus D and C minus D we are going to add, we will be getting B plus B, it is equivalent to A plus D plus C minus D. Plus D minus D will be cancelled. It will be 2B will be A plus C. That means your B could even be written as A plus C by 2. That's the reason B is known as the arithmetic mean of these two numbers. If it is a middle number, middle number will be the arithmetic mean of the first and third number. Now in certain conditions, like there are some problems, like if there are three terms and the sum of the terms is this and the product of the terms is this. So in these type of questions, if we will be having two unknowns, it will be difficult for us to solve the equations. So for that convenience, what we do is, if there are three terms, means if odd number of terms are there, we will be assuming the terms to be, first term to be A minus D, second term is A, and third term is A plus D. Why we are doing this? Because it is given to us that sum of three terms is your, suppose 15 is given. So if sum of three terms, first three terms is 15 and product of three terms is given to us. So if we will add these, A minus D plus A plus D is equivalent to 15, it is given. So if we will add, we will be having an equation in one variable only, that is a plus a plus a. 3 is equivalent to 15 and we will be getting the value of one variable. So whensoever odd number of terms are given, we will be assuming it to be a minus, if 3 it is, so it will be a minus d, a and a plus d. And if 5 terms are given, so we will be assuming terms to be a minus 2d, a minus d, a plus d and a plus 2d. Here if we will be adding these, so minus 2d plus 2d will be cancelled, minus d plus d will be cancelled, and there will be an equation in one variable only that we can easily solve and find the value of that. Now if the number of terms is even instead of odd number of terms, if the number of terms is even, in that case if it is 4, so we will take the terms to be a minus 3d, a minus d, a plus d and a plus 3d. Again if it is given that is sum of 4 terms is whatsoever the number is given to us. So if we will add all these 4, minus 3d plus 3d will cancel, minus d plus d will cancel, and we will be getting an equation in one variable that we can easily solve and find the value of the variable. Now here in these cases, your first term is your a minus d. Instead of a, first term is a minus d, a is your second term and a plus d is your third term. And common difference over here we can see that the common difference is your d only. But let's just remember that first term is not a, first term is a minus d. Similarly, if we are going to take these type of cases, your first term won't be a, first term will be a minus 3d, second term will be a minus d, third term will be a plus d and fourth term will be a plus 3d. So from here we can say that the common difference d is your 2d. It is not only d. Common difference is your 2d, because if you will be adding 2d in your this first term, you will be getting the second term. If you will be adding 2d in the second term, you will be getting the third term. So this you need to remember that here first term will be a minus d and common difference will be d. Here first term will be a minus 3d and common difference will be 2d. But it is always convenient to take these as the terms. Whensoever it is odd, take these. Whensoever it is even, it will be like that. And if it is instead of 4, it is 6 terms are given. So we will be taking it as a minus 5b, a minus 3d, a minus d, a plus d, a plus 3d and a plus 5d. So from here minus 5d plus 5d cancel, minus 3d plus 3d cancel, minus d plus d cancel, and we will be getting an equation in one variable only. So hope it is clear how to take the terms if it is odd or if it is even. Now if two APs are there and they are having the common difference is same, common difference of two APs are same, then difference between their nth term will be equivalent to the difference between their first terms only. Just let's understand this with an example. Suppose your one of the series is simple series. We are taking 1, 2, 3, 4, 5, 6. This is one of the series. It is in AP. Here your common difference is 1. So we have to assume one more series with the same common difference only. Suppose our series is starting from 5. Then because common difference should be same for both the two series, so we have taken this to be series, and here even your common difference is 1. So what we were saying, if there are two APs in which common difference is same, then difference between their nth term will be equivalent to the difference between their first term only. Now suppose we are assuming difference between their fifth term. So here the fifth term is 1, 2, 3, 4, 5. This is the fifth term. Here 1, 2, 3, 4, 5. This is the fifth term. So difference between the fifth term of the APs is 9 minus 5, that is 4. And difference between their first term is 5 minus 1, that is 4. If instead of fifth term we are taking the third term, difference between their third terms. So third term over here in this series is 3 and here it is 7. So difference between the third terms will be 7 minus 3, that is 4. That means whatsoever the term you are taking, whether you are taking 100th term, whether you are taking 1000th term, or whatsoever the nth term you are taking, the difference between these type of series will always remain the difference between their first terms only. Hope these are some important points which are sometimes used in solving so many types of questions. Now we'll be coming with some more questions related to it. Now let's see some questions based on sum of n terms of an AP. The sum of nth terms of an AP is given by Sn is equivalent to 2n square minus 5n. So what will be the fifth term of AP? Just we discussed that if we need to find the nth term of an AP and the sum is given to us, so an will be Sn minus 1. This will be the value of an. We can find the nth term from this formula. Now we have to find the fifth term, that means value of n is 5. And for finding A5, we need to find S5 minus S5 minus 1, that is S4. So here given to us is Sn is equivalent to 2n square minus 5n. If we will be keeping n is equivalent to 4 here, this will become sum of 4 terms is 2 multiplied by 4 square minus 5 times of 4. Wheresoever n was written, we have kept 4. So it will be 4 4 is 16, 16 2s are 32 minus 5 4 is 20. So sum of 4 terms will be 12. Now if sum of 4 terms is 12, we need to find sum of 5 terms also. So S5 will be, we will be keeping wheresoever n is coming, we will be replacing this n by 5. So S5 will be 2 multiplied by 5 square minus 5 multiplied by 5. So this will be 5 is 25. 25 into 2 is 50 minus 25. That will give us 25. That means sum of 5 terms is 25 and sum of 4 terms is 12. So we can say that the fifth term will be A5 will be sum of 5 terms minus sum of 4 terms. That will give us sum of 5 terms is your 25 and sum of 4 terms is 12. So it will be 13. Fifth term will be 13. So using this formula, we can find the term if sum is given to us. Now the next question is find the sum of 10 terms of an AP, that is a 17, 12, 7. This is AP. We have to find the sum of 10 terms. That means n is given to us as 10 and we need to find value of as 10. Sum of 10 terms we need to find it out. From here we can see the first term is 17. That means value of A is 17. Common difference D is your second term minus first term. We can take it as, that means 12 minus 17, or we can say it to be minus 5. The common difference is minus 5. Now we are having the value of A. We are having the value of D. We know the value of n also. So Sn is n by 2, 2A plus n minus 1 into D. This is the formula. We will be keeping all these values here. So S10 will be n is 10 by 2. 2 times of A is 17 plus n is your 10. So 10 minus 1 multiplied by D is minus 5. So we will be solving it further. It will become 10 by 2 multiplied by 17 into 2 will be 34 plus 10 minus 1 is 9. 9 multiplied by minus 5, it is 45. But it will be minus sign. So minus of 45. So this will become 10 upon 2, 34 plus minus will become minus 45. That will be, we can write this as 5 also. So 5 multiplied by 34 minus 45 will be minus of 11. That is your minus 55. That means sum of first n terms of the AP will be minus of 55. Because it is your D over here is negative. So these numbers will come, gradually it will come in negative side also. So that's the reason your sum of first n terms will be your minus 55. So this is how we will be using the formulas and we will be solving various problems related to AP, that is your arithmetic progression. Hope the topic is clear to you and you must have liked the videos also. So we will be coming back with more videos related to mathematics. Thank you.